Hi students, welcome to this video session. I remain Samuel Chukwuemeka, aka Sam Dam for Peace. In this video session, we shall discuss similar problems to your Module 4 homework in discrete mathematics. This part 1 will cover the first 4 questions, and the first 4 questions deals with combinatorics. Okay, fundamental counting principle, permutations, and combinations. So please, it is recommended that you have viewed all the videos in the video playlist on combinatorics on my website prior to viewing this video. Alright, and if you have any questions, please feel free to ask. Question 1. Suppose that a company will select 3 people from a collection of 12 applicants to serve as a regional manager, branch manager, and assistant to the branch manager. In how many ways can the selection be made? Explain how you got your answer. I repeat, suppose that a company will select 3 people from a collection of 12 applicants to serve as a regional manager, a branch manager, and an assistant to the branch manager. In how many ways can the selection be made? So you see there is a position. Okay, the question, this is order. Okay, and whenever we talk about order, we talk about permutation. Arrangement of items, selection of items with regards to the order of arrangement or with regards to the order of the selection. So there's an order there, and the order is that these 3 positions are specific. Okay, the regional manager, branch manager, and assistant to the branch manager. If they were just selecting 3 people from 12 applicants for any position, okay, then we will use combination. However, there is order here because they mentioned a regional manager, branch manager, and an assistant to the branch manager. Therefore, in this question, we shall use permutation. Please, before we continue, let us write the formulas that we need. We see that the n factorial is n times n minus 1, okay, times n minus 1 times n minus 2 times up to 1, up to times 1, okay, up to times 1. That is n factorial. N permutation r will give us n factorial over n minus r factorial. N combination r, palm r from n palm r, combination n com r, com r from n com r will be n factorial over n minus r factorial, Okay, so as you can see here, n palm r is actually n com r divided by r factorial, or we can say that n palm r is n com r times r factorial. N palm r is r factorial times n combination r. Okay? Or we can also say that n com r is n permutation r all over r factorial. So let's just have these formulas. Okay? We have these formulas here. So question 1, because it is with order, the number of ways would be 12 permutation 3. And that will give us 12 factorial over 12 minus 3 factorial. And that will give us 12 factorial over 9 factorial. And that will give us 12 times 11. I am using asterisks as times, okay? Let me use asterisks as times. Asterisks as times. So this would be 12 times 11 times 10 times 9 factorial, all over 9 factorial. We just stop at 9 factorial. We don't need to keep writing the whole thing because this will cross out this. Bam, bam. So the number of ways will just be 12 times 11 times 10. Okay? And that will give us 12 times 11 times 10. 1320 ways. 1320 ways. That's it. Okay? Question 2. How many distinguishable permutations can be made of the letters in the word mathematics? How many distinguishable permutations can be made of the letters in the word mathematics? Mathematics. So this is a permutation with repetition. We call it permutation with repetition, or we call it permutation of duplicate items. Okay? So this will be, we find first, let's count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial all over. Now let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 factorial over. Let's see the ones that are duplicates. Let's see the duplicates. So n and m are duplicates. So we write 2 factorial times a. I circle this one, and a is a duplicate. I write 2 factorial times t. Let me use rectangle for t here, and t also here is a duplicate. I write 2 factorial. 2 factorial. H, no. E, no. We've used MAT. Now I, no. C, no. And S, no. So this is what we get here. And of course, this will just give us 11 factorial over 2 times 2 times 2. So 11 factorial over 2 times 2, 4 times 2, 8. Okay? Actually, we would have written the whole thing, but that is too much. So 11 factorial. Let us find 11 factorial here. In the videos, in the playlist, I showed you how you could use your calculator to get factorial. Okay? Or the calculator on your computer to get factorials, permutation, and combination. So let me Let me locate the factorial in my, I know factorial must be somewhere. 11 factorial. I know it must be somewhere in mine, but you know, because of time, I will just go ahead and do 11 times 10 times 9 times 8. Actually, you know what, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 8. Okay. Now you will just, you know, because of time, this is because of time I will just do the multiplication. But you can also locate factorial in yours. Okay. So when we multiply that, we have 11 times 10 times 9 times 7 times 6 times 5 times 4 times 6. 3 times 2 is 6. And that gives us 498 9600 ways. Okay? That's the answer. 498 9600 ways. Alright. Let's do question 3. This is straightforward, right? Pretty much straightforward. Question 3 says, in how many ways can a committee of 12 Republicans and 3 Democrats be chosen from a group of 16 Republicans and 7 Democrats? I repeat, in how many ways can a committee of 12 Republicans and 3 Democrats be chosen from a group of 16 Republicans and 7 Democrats? So the number of ways would be, here, you know, there's no specific function for it, so this is combination. This is without order. Okay, we can choose. We would just want to form a committee of 12 Republicans and 3 Democrats. From a group, we're given a group of 16 Republicans and 7 Democrats. And we just have to form a committee from that group. So it is without regards to order. So if it's without regards to order of selection, it is combination. We use combination. If it is with regards to the order of selection or order of arrangement, we use permutation. So in this case, this will be 12 Republicans from 16 Republicans will be 16 combination 12, then times 3 Democrats from 7 Democrats will be 7 combination 3. So this will give us 16 factorial all over 16 minus 12 factorial, 12 factorial times 7 factorial all over 7 minus 3 factorial, 3 factorial. So this will give us 16 factorial all over 4 factorial times 12 factorial times, because 16 minus 12 is 4, times 7 factorial all over 4 factorial times 3 factorial. Okay? Let me put these times so you don't think it is times 12 factorial. So 4 factorial times 3 factorial times 3 factorial. So you don't mistake it. Okay? And this times here, times 12 factorial. And here times 3 factorial. Times 3 factorial. Alright folks, let's do this. So this will give us 16 times 15 times 14 times 13 times 12 factorial. You see the thing, even if I don't want to use calculator, okay, I'm going to use calculator at least, but if I want, even if you're asked not to use calculator, you can still do this by simplifying it. So the highest here is 12 factorial. So I stop at 12 factorial because it will cross out anyway. Okay, so I can write my 12 factorial, then times 4 times 3 times 2 times 1. Okay, then times 7 factorial. The highest here is 4 factorial. So I will stop at 4 factorial. So this is 7 times 6 times 5 times 4 factorial all over 4 factorial times 3 times 2 times 1. Okay? Bam, bam. That's gone. Alright. 4 times 2, 8. 4 times 3, 12. 3 times 2, 6. Okay, 4 times 3, 12. So I'm just gonna do this. 4 and 2 is 8. 4 times 2, 8. 8 into 16 is 2. Okay? And then 3 into 3 is 1. 3 into 15 is 5. So I have 2 times 5 times 14 times 13. Okay? Times here 4 factorial. Bam, bam. That's gone. 3 times 2 is 6. Bam, bam. So I have 7 times 5. Okay? So 2 times 5 is 10 times 14, 140 times 13. So I have 1820 times 35. And that gives me 63700 ways. 63700 ways. Okay? Okay. Question 4. Last but not the least. For this part 1. Please, part 2. Actually, well, let's finish part 1 first. Okay? Then we can talk about part 2. Question 4. We have a fair 6-sided die. A fair 6-sided die is rolled 7 times. A fair 6-sided die is rolled 7 times. Okay. And the result is recorded for each row. The result is recorded for each row. A, you have 2 questions here. A, how many different sequences of results are possible? How many different sequences of results are possible? Okay, let's do A first. So A, now when you roll a die 7 times, you roll it 7 times. So you could get how many? You could get possibilities. Possibilities. When you roll it 7 times, you could get 1, 2, 3, 4, 5, 6, 7. You could get 1, 2, 1, 1, 1, 1, 1, 2. Okay? You can get 1, 1, 1, 1, 1, 1, 3. You could get 1 on the first row. You roll it 7 times. You could get, please don't mind my dog, okay? Don't mind my dog. So anytime my dog hears my voice, she wants to come into the house. But if she comes into the house, I can't teach, you know? Okay, so you could get 1 on the first row, 1 on the second, 1 on the third, 1 on the fourth, 1 on the fifth, 1 on the sixth, 3 on the 7th row. This is a fair die, a 6-sided die you're rolling. Okay, imagine don't do this thing, it's too much. Too much. So you see that for each one, this is ordered. And after this, you could even have 3, 3, 1, 2, 1, 5, 6. Possibility. And so many. And so many more. Now, how do you find the whole sequences? So you see, this is not a combination. This is ordered. It's ordered. For each one, it is ordered on what you could get. So this is permutation. So the way you now do this, the number of ways. Okay, these are a lot of the sequences you could get when you roll it. Okay, first row, second row, third row, fourth row, fifth row, sixth row, seventh row, until the last one will be 6, 6, 6, 6, 6, 6, 6. That's the last one. The first one is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. And you keep on doing until 6, 6, 6, 6, 6, 6, 6. Because it's a 6-sided die. Okay? So the number, the sample space, the cardinality of the sample space, or we can say number of possibilities, okay, will give you, because you're rolling this, because you're rolling this 7 times, okay, and you know each die is 6, okay, so you have 6 palm 1 times 6 palm 1 times 6 palm 1 times 6 palm 1, okay, times 6 palm 1, 1, 2, 3, 4, 5, times 6 palm 1, 6, 7, 6 palm 1, 1, 2, 3, 4, 5, 6, 7. These are the possibilities because each one is ordered. Each one is ordered. You can only get 1 out of 6 and it is ordered. So this is case of permutation. So 6 palm 1 gives us what? 6 palm 1 gives us 6 factorial all over 6 minus 1 factorial. Okay, so this is 6 factorial over 5 factorial, which is 6 times 5 factorial all over 5 factorial, which is 6. So actually the number of possibilities is 6 times 6 times 6 times 6 times 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is like saying 6 raised to power 7. Okay? The number of possibilities. So you have 6 exponent 7. And that gives you 279936 sequences, right? It says how many different sequences. Okay? Different sequences of results. This is what you can get. Okay? That is the way you do this. Yeah. Okay? This A part. Now let's do the B part. B part, this A part. It says, of the possible sequences of results, how many of them contain exactly 3 rows of a 4? Exactly 3 rows of a 4. Of all the possible sequences, of all this here, how many will contain exactly 3 rows of a 4? That's 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. It could be 1, 1, 1, 1, 4, 4, 4. Okay, 3 contain exactly 3 rows, 3 of 4. Okay, it could be 4, 4, 1, 4, 1, 2, 3. You see? It could be that. So now, in this case first, we see that we are looking at 3 rows of a 4, which means 4, 4, 4. And this is 7 times. We will roll this 7 times. So we just won, okay, any one, we really don't care the order in which the 4, in which we get the 4. We don't care the order in which we get the 4. We don't. All we know is that we won 3 4s. That is all we know. What we know is that we won 3 4s. We don't care, out of these 7 rows, okay, all we want is at least we won all the ones in which 3 of those rows, because each case is 7 rows. Each case is 7 rows. We just won all the rows in which 3 of those rows out of 7 gave us 4. 3 rows out of 7 gave us 4. That is what we want. We won all cases where 3 rows out of 7 rows gives 4. That's what we want. Okay, that is not permutation. That is combination. So the number of ways would be we have 7 combination 3. Okay, we've not finished. Now, once we get 4, 4, 4 in 3 rows, okay, we still have 1, 2, 3, 4. We still have 4 more. Okay, we still have 4 more. Because even if we get 4, 4, 4 here, what about other ones? 1, 1, 1, 1. 1, 2, 2, 3, 4, 4, 4. 4, 1, 2, 4, 5, 6, 4. Or something like, just making it sure. So what about when we get that case in which 3 rows is 4, we still have 4 other cases, which those 4 other cases now gives us permutation. The other 4 rows, we don't want any 4. We don't want any 4. So we have actually 1 through 5. The other 4 rows remaining, we don't want anything We want anything besides 4. We don't want anything 4. So it could be 1, 2, 3, 5, 6. And it will now be permutation. The other 4 dice remaining. And it will be permutation. So this will be 5 pound 1 times 5 pound 1 times 5 pound 1 times 5 pound 1. 1, 2, 3, 4 plus 3, 7. Yeah. See that? Okay? So let's finish it. Let's finish that. So this will now give us 7 come 3 is 7 factorial over, we've done 7 come 3 before, right? We got 35. We got 35, right? Yeah, 4 factorial. I think we got 3 factorial here. We got this as 35 when we did it earlier on. Okay? Then 5 pound 1, I mean, we can also do it again. So this is 7 factorial over 4 factorial, 3 factorial, which is 7 times 6 times 5 times 4 factorial, all over 4 factorial times 3 times 2 times 1. 4 factorial crosses out 4 factorial. Gone. 3 times 2 is 6. Okay? So you have 7 times 5, which is 35. 5 pound 1 will give us 5 factorial all over 5 minus 1 factorial. And that is 5 factorial all over 4 factorial. Okay? And that is 5 times 4 factorial all over 4 factorial. And that is 5. Because 4 factorial will cross out 4 factorial. So the number of ways we have here, from here, will give us 35 times 5 times 5 times 5 times 5. And that will give us 35 times 5 to the 4. 35 times 6 to 5, right? Because 5 to the 4 is 6 to 5. Okay? And that is 2, 1, 8, 7, 5 sequences. Okay? Thank you for listening. For questions 7 and 8, for questions 7 and 8 in your homework, please look at that video playlist on a module homework and exam study guide. For questions 7 and 8, view the video on recurrence. Okay, you will see it in that playlist, and that will take care of questions 7 and 8. Okay, and you watch out for videos that would give examples for questions 5 and 6. All right, thank you so much for listening. If you have any questions, please feel free to ask, and you have a good evening.